Eisdrift ist null. Der Wetterfrosch sagt eine Eisdriftänderung voraus aufgrund von Wind und so etwas. Und das Schiff versucht sich jetzt schon vorzubereiten für die neue Eisdrift.
Working meeting in the Hamburg Ship Model Basin. The challenge to the engineers to keep Aurora Borealis on position in drifting ice, which means ice breaking at no vessel's speed, only about half a knot of ice drift speed.
Beim Ridge, da ist der Kanal durch und dann hier fahren.
This daily situation needs to be simulated in the ice tank, as it is impossible to move the ice itself in the tank. In these tests, the vessel is moved with very low speed against the ice, emulating the natural process. Within the given physical constraints of the ice tank, it is neither feasible nor technically possible to move the ice itself. The ice has certain boundary conditions that are dictated by the test tank. The force and acceleration acting on the different parts of the hull are the decisive factors. It is thus physically the same principle, whether one moves ice against a vessel like in reality or vice versa. The important thing is to correctly calculate and extrapolate the resulting real-world forces and dimensions.
Und man rechnet das dann entsprechend zurück in real auftretende Kräfte und in real auftretende Beschleunigung von dem Eistank, um das zu extrapolieren in die Realität.
Test manager Dr. Karl-Heinz Rupp directs the vessel against the ice. With every test, more than 70 parameters are recorded by his colleagues. The tests are as diverse as nature itself. Here the vessel is moving through an already broken ice barrier, like often done in Antarctic waters. A sophisticated propulsion concept was developed to keep the ship on position. 6 transverse thrusters are located below the vessel, pushing the ship on a command either to the port or starboard side. Swivelable or azimuth thrusters are very prone to technical failures. Thus, Aurora Borealis was designed with more robust fixed thrusters that can be retracted into a tunnel within the hull. All movements in all directions can be realized with a combination of these thrusters and the main propellers.
The
concept features the following novelties. A concept with 3 propellers to transfer the power into the water. As a result, we can realize propeller sizes that are located deep enough to experience no ice damage. For the ice breaking and drifting ice with very low speeds, we developed heeling systems to support ice breaking with virtually no vessel speed in forward, reverse, and sideways directions. This allows to keep the vessel free from ice and maintain position.
Und zwar sowohl in Längsschiffsrichtung als auch in Querschiffsrichtung, und damit können wir praktisch in allen Richtungen das Schiff freiboxen vom Eis und auf Position halten.
To dynamically position in drifting ice, one of the most important features of the Aurora Borealis. The tests have proven that Aurora Borealis keeps position even if thick icebergs press against her sides. The ice measures only centimeters in the ice tank. In reality, these chunks are giant ice projectiles working against the ship. Aurora Borealis prevails. July 2008, Helsinki. The experts from the Alfred Wegener Institute and the engineering office on their way to the ice test tank of Aker Arctic. Besides the Hamburg Ship Model Basin, this is the only other facility of its kind in Europe. Here, the ice conditions and the model scale are different. The question, will the rest results be the same as in Hamburg, or are they different? Will Aurora Borealis be once again tested successfully under entirely different boundary conditions? But the first tests already show Aurora Borealis is not stopped and breaks the ice with ease. The most important systems remain ice-free underwater, and if something remains in the way, it is simply cleared by Aurora Borealis. The open accessibility of this ice tank is impressive for all. Here, you can watch spot on. Here we can observe very well how the ice is reacting to the braking, how it is transported along the hull, and how the sensitive systems of the ship, like thrusters, echo sounders, remain without ice contact, or how the main propellers are outside the main ice flow underneath the vessel. This to us is an important insight into how well our initial concept proves to be successful. Aurora Borealis has a draft of 13 meters during ice breaking. In transit mode, only 11 meters. Impressive! Aurora Borealis breaks giant ice barriers as big as 5-story buildings in reality. In this test, all transverse thrusters are retracted. In case of damage, these thrusters can be hoisted through a service tunnel onto a higher deck level for onboard autonomous servicing and maintenance. This ice barrier would have a length of several hundred meters in reality. The biggest ice masses are hidden underwater in the polar seas. In this test, the ice ridge would be 12 meters thick. Aurora Borealis cuts this obstacle like a piece of cake. All observers of the test series agree. This ship is well suited for all future research tasks, like geology, geophysics, biology, and bathymetry. Polarstern is now 25 years old. When it was designed, one didn't imagine the increased needs for research capacities and the diversity of different researchers' teams. On Polarstern, therefore, space is limited in labs and living quarters. Aurora Borealis will be different. The increase in space allocation, also for the drilling operations, is already calculated and incorporated into the layout. The next test, turning in ice. Here shown in fast forward. The focus always remains on safety and robust design. The most important guidelines for the engineers, also for the primary task of the vessel, dynamic positioning in ice. During drilling, the vessel is always positioned with a bow towards the drifting ice. If the wind direction and ice drift changes, the ship is immediately turned to regain the optimal ice braking position. To achieve this, many components have to be coordinated. The current design of Aurora Borealis proves that ice can be broken sideways with the hull. It can also be shifted sideways with the transverse thrusters to starboard or port side. The powerful main propellers can maneuver the vessel into any given position. And if necessary, she can also break ice astern. Because of the multitude of positive test results, the engineers are sure that the ship could be built according to their specifications.
Wir haben völlig neue und unterschiedliche Erkenntnisse.
We gained completely new expertise because the methods of the two test tanks are entirely different. This means we were able to observe characteristics in one tank that were not traceable in the other, and vice versa. Taken together, these results are qualifying the design as being feasible for construction, as anticipated by us.
Dass wir mit dem Schiff die Performance bringen können, die gewünscht wird.
Other considerations are progressed in parallel to the technical tests in the ice tank. In the Alfred Wegener Institute, meeting of the working group for the transportation systems. Here, everything focuses on logistics.